we're into part 3 of my distribution box build, which is this fancy creature up here with all the bright blue lights and the voltages. So, what bit do we get in next? The bit that goes in that hole, which is my continuity beeper. And these things, we'll dismantle one on camera just to give you a look. So, they are a 12 volt AC unit, which they seem to work quite fine on DC, which you would expect from a lot of solid state stuff. Little lock ring here, which we're going to remove, and we can remove this cap here. Have a quick look underneath. So underneath here is a little PZO buzzer and a couple of surface mount LEDs, and in between this grill you may be able to see, I'm not sure, but there's a couple of resistors, and that's about it. Now, I discovered that these things work rather well on 12 volts, but they're also really noisy. So these things, we're going to test one of these on 12 volts. So ironically, using the very unit that we're going to replace it with, which is that unit there. So let's have a look here. Let's give ourselves 12 volts from the house battery, and we'll test one of these, polarity not being an issue. So they have a pulsing unit, very, very noisy. What I did discover is that if I put this unit back here and we go up to our unit and switch on 9 volts, they are at quite a comfortable volume, especially considering I'm only working right next to it. So let's try this out on 9 volts and see. Similar to the volume on my multimeter, which is much better. And apparently I've got some messages as well. Let's go and check those messages and I'll come back to this. And we're back, having yelled at people for messaging me in the middle of videoing. So this is what I've prepared. Keep in mind I bought several of these. So this little monstrosity, rather than open this up and build it inside, which I decided I couldn't be bothered, I wired up an LM7809 9-volt regulator, which is exactly the same thing I have in my distribution box. I've just stuck it in a little bit of heat shrink, as I don't need a heat sink, there's my terminology right, because I'm not going to be pulling very much current at all through this, whereas the one in the distribution box might need the full 1.5 amps. I've also tape flagged the ins and the outs and whatnot. So when we go along here and reconnect our in to our 12 volt positive, just switch over in the distribution box in the background here, and then we go and do this. And my apprentice had some fun testing this for me. Nice and quiet now, so we can proceed to put that in the box. Now, one other thing I discovered, and this is handy when you buy a few of these, being so cheap, they didn't actually lie about the hole size. So let's check over here. It fits perfectly, so I'm quite happy about that. So let's get this cover off and get on with the attachment. After this there'll be only one more unit to come, and that will be the USB supply, which I think is not too far away. Incidentally, this is what you get when you order one set of leads. You get one lead. So be careful to read the terminology on the pages very carefully when shopping on AliExpress. So this is going to be a slightly difficult angle to get, but I'm going to try my best here. So we have our in wire here, which is voltage in. I'm going to grab that off the continuity check terminals here. You'll probably notice from this angle that I've already mounted the unit. Now I'm trying to just position this wire just nicely. I have already tinned the rear of these terminals, and before you ask, I am aware that these are generally intended to be used as screw terminals, but given the nature of this, I'm going to, and the size of the wire, I'm going to use direct soldering, and there's usually less crimped terminals to go wrong in here. So we have ground. What are we going to do with this? Well, I happen to have terminated all the grounds right next to where this is intended to go. So because there is a lip on the box, I'm going to thread this in the other way just so that we don't have some sort of weird freakish wire hanging out the side. Now my roll of solder is over here, and let's quickly put a blob on here. Get it nice and warm to amalgamate with the rest. That looks pretty good. So that's our negative, which is passed straight through to the center pin of the LM7809, the other side being in and out. So what's next? All our wires are accounted for except for the ground on this. So we're going to pick the ground up off the 12 volt input, which is going to, and that sounds weird, but negative is going to pass through a circuit, come back out this side, which is connected to the positive input of the regulator. So from here I need to find some new wire and make a link. Alright, we have a nice length of wire here. You might be asking yourself why I'm using figure 8 cable for this. The simple answer is I have a lot of it kicking around and I don't like throwing wire out when it's still useful. Plus this is all very low current stuff. So I've tinned the ends of this. This one's got a little blob on it, but we'll clean that up. And I've used the trace wire. There's that bloke that always has timing that is worse than, in fact I don't know what I can think of as worse timing, but we'll rant about him in this video because he'll probably be watching this later. In any case, you know who you are. So back to the job at hand. We need to solder this positive wire. So we're going to grab this off the negative terminal because this is a continuity check, so we're not really doing anything too drastic. These people that are scared about connecting red to black. So I'm going to poke this through the middle of some of this just to keep things a little neater. And you know what? I might actually trim this to length a little bit. Oh, you know what? I'm probably going to have some trouble and I'm going to need to rewire this, so a little bit of slack wire will probably be handy. So we're getting 12 volt from that side of the switch, which is through the fuse. So that is our 12 volt common rail there. So I believe I need to solder onto this. Well, that little click you saw there is what I was worried about when I said there is a ground loop with the UPS in the other room. So what I do need to do now is stop, disconnect my 12 volt source and find a battery source. One moment. A very noisy distribution box on the corner of my desk. It has a self-illuminating fuse box, which is where I got the idea for the LED fuses. You can see here the red light indicates the fuse for the distribution panel. That being lit up means that I've disconnected the fuse. We can see now that I've removed the fuse, there's enough current flowing through to light an LED, but not enough to light up the actual voltmeter. So that is what we want to see, which should reduce the current enough not to create a dead short. I am still going to test this with a quick touch. Okay, I think we've dropped the current loading off enough to make a solder join. For the sake of good footage, I'll use some battery light source here as well. Let's just solder this on. Okay, we're on, which now means we can reconnect the fuse. Turn our extra light off and let's reconnect the fuse. You probably can't see much in here, but we have a 30 amp fuse holder. A 30 amp fuse in the fuse holder, and we have a little plastic shroud. It's back on there. Okay, let's try from the other end. Let's try smoke test. Let's check that we have normal function on all circuits. I'll turn on my variable supply, which should give us a random voltage. Let's dial it up a bit. I know where there's nothing from that. There is these things. This is the bypass to the variable supply. I'll plug that back in. Let's go back down here and see if we have variable supply. That's good. And we'll just whiz up and down for, theatrics. Alright, so the next thing we need to do is check for continuity. I'm having a little look around here. These are my short test probes. We have banana plugs one end, clips the other end. These are the ones that were responsible for the demise of the Amiga keyboard input, which I'll be buying bits for tomorrow. Had a little bit of a heart attack moment there when the screens just went blank. In any case, we have 2 connections in there, and we should be able to go so that works as a continuity check. So now we just need to put the front panel back on and double check the function. Oakley dokley, YouTuberinos, we have a finished product. Right, these are all looking very good. So, although I think my switches look a little bit cockeyed, that might be just the way I'm looking at them. Okay, so let's do a function test, because things often go wrong when you try and make them work right. Now, where did I put my clip leads? I might have to cut briefly while I find them. They were hiding under the desk, but my under desk lights worked well. So here is our continuity test. Let's put these around a different way so that you can see the pretty lights. It might be worth noting that polarity is not really not that much of a problem. Looks pretty cool, doesn't it? Especially when we light everything up and might be mistaken for something more nefarious. But that part's good. There's that guy sending me messages, or he's tagging me and stuff again. I should really log off Facebook before I start this stuff. Anyway, we can see here, this is the very last part of the project that will be arriving soon. I do have another LED to fit in here, which will be one of these green guys, which, in case you haven't seen these are the fuse blow indicator lights that turn on when the fuse is blown. These are M205 fuse holders. Again, if you haven't seen the other videos, this is a quick recap. This is 12 volts direct from my house battery, which is run from around about 200 watts of solar panels. There's a 9 volt 7809 regulator. There is a 5 volt pack, which was going to be an LM7805, but turned out we ended up using a 3 amp 5 volt regulator from China. This input here, when I turn on the correct switch up the top, is a direct line from a variable power supply, variable voltage and variable current. So that is handy. We can turn that off. It will gradually drain the capacitor out. We should see that shortly. I do believe there is a rather large capacitor in there. Let's turn it off and see what happens. There we go. Now, the power supply to this switch is fed off the common rail of everything else, and there is an isolation relay so that anything coming out of the variable supply has a floating ground, which is handy in some situations. So, let's see if we can plug some probes in and test something for real. So this is a dead DVR board, or digital video recorder, for those who are not familiar with the acronym. It did have a button cell holder in it, but we removed that in the Amiga 2000 video so that we could put a new BIOS battery in. And also featured in that same video were these hypodermic needle size test probes, which I expected to be much bigger. Nonetheless, they've turned out to be very handy. So if we test out our newfangled continuity tester here, sorry about that interruption, I slipped with the needle and nearly stabbed myself. So we can test here. So now we should be able to probe, let's say, the ground trace, and from one point here to another point here. And let's try the shield off one of the BNC connectors. Is apparently not common grounded. There we go. So it looks like a success. This is actually going to be quite useful, especially when my inside meter doesn't have an audible continuity beeper. My good quality one that I carry around in the vehicle, it really needs to live in the vehicle, so it has continuity beep. But inside, this is my version of a desk multimeter, so we're doing pretty well. In either case, it's a success, and I'm really hoping I get my 3 amp USB thing. That I expect is going to be another fairly simple fit. But yeah, let me know what you think. This is a pretty short video, and we're getting very nearly into this project, so alright, onwards to the next video. Thanks for watching.